This section is about the X-ray machine. The X-ray machine, as we see, it consists of a voltage source, a high voltage source, which ranges from 20 to 100 kilovolt, and it provides what we call the anode cathode volt. The anode cathode volt, the negative terminal is connected to this side that has a filament here, and this will be the cathode, and the other side is the target metal, which is the anode, and we will see why we call it a target. There is a filament here. The filament is heated by another circuit by an alternating voltage. As we see, electrons of the filament will gain thermal energy and will be freed out of the filament to enter the anode cathode. Voltage will accelerate these electrons. Work done on electrons will drag them from the filament or from the cathode towards the anode, in which they will gain kinetic energy, and then they will enter in a collision with the target, or the metal anode here. The target, this is the target. The target consists usually of a metal like tungsten, as electrons are gaining this large or broad distribution of kinetic energy. They will hit the tungsten, and X-ray will be emitted to go out through the X-ray window. Now we will go into details of what is happening inside the tungsten over here. I'm going fast because you know the details here. First, the electrons. Somebody asks about the electrons and the energy that they gain. You know that the kinetic energy is equal to QV, which is in this case EV. This is the charge of an electron, and this is the anode cathode volt, which can be represented by VAC, anode cathode volt. And it is clear that the kinetic energy is directly proportional to the anode cathode volt, as we will see later. But let us, as I told you, go to the tungsten here to see what is happening. The metal of the tungsten usually contains a specific number of electrons. I believe it's like 74 electrons around its nucleus. So let's consider that this is an atom of tungsten, the nucleus, and let's consider that this is an electron that is accelerated coming from the filament. Now what happens to the electrons that is possessing high kinetic energy? What happens to this electron as it passes close to the atom? We say that it breaks down, or let's say it just decelerates. While decelerating, it will undergo some deviation. This is actually due to the interaction between electrostatic interaction between the electrons and the nucleus of the tungsten element. Due to this deceleration, part of the energy which is acquired by the electron while moving from the anode to the cathode, part of this energy will be lost and changed. Actually, it's not lost, it is just changed or transformed into another form, and this form is a photon of X-ray. It's an electromagnetic photon that lies in the X-ray range. So it is having an energy E equals to HF. This frequency is in the X-ray range. So this is the first part of the X-ray. Now I need you to pay attention very well that there will be a large distribution of the frequencies. I'm not going to have a specific frequency. I'm going to have a large distribution. Why? Because not all electrons are having the same energy, same kinetic energy. As I said, there will be a large distribution. Actually, it is not discrete, it is continuous distribution, and this will form the curve that we will talk about later. Okay, now another part of electrons will do something else. Another electrons will actually hit some electrons that are found in some lower levels of the tungsten element. Now, while hitting these electrons in their orbits, both electrons, the bullet and the target, both of them will be scattered away, leaving here what is known as a hole or a gap. This gap will eventually be filled with an electron that is found in a higher shell. As this electron goes down to this hole to occupy this empty hole, of course, look over here, this electron is possessing more energy in its upper level than the energy of the lower level. So while it's going down in what we call de-excitation, this electron will lose the energy, or the difference in energy will lose it or will emit it as X-ray also. So I noticed here that I have two types of X-rays emitted. The first type is emitted by, as we said, the deceleration of the electrons as it passes close to the nucleus, and the other part is emitted due to the de-excitation of the electrons in the orbits of the tungsten elements. So I have two types of X-ray emitted over here.